first one. And, okay, so again, and Annie, you weren't here yesterday. It's like an ellipse, but it has a subtract in the middle. And because it has a subtract, a hyperbola, this is a hyperbola. And it goes off of whoever comes first. The first term is the major axis. And then that will take the A, that will take the B. So this guy will be the A squared right now, this guy will be the B squared. If Y comes first, it will still be the A squared, that will be the major. This is where you transverse off of. So it's going to open up on the X's, somewhere this way. If the Y was first, then it would open up the other way. Yeah, because it's these two that'll change. A and B will stay like this.
How about when they give you the long one where you have to, what's it called? To group them together. How do you know which one?
Well, you don't know until the very end, until you make your equation equal to 1. Because sometimes, like the one in the example we did yesterday, we had to divide by a negative, which forced those to swap. So you don't know till the very end, till you put your minus in the middle. So the rest kind of works the same. Your foci this time are outside of this. If I did this, and I could kind of make this an ellipse from here, it works like an ellipse, but because it's a hyperbola, then instead of making an ellipse, we make a rectangle. We make our asymptotes to go through our rectangle, and that guides the hyperbola. I use this as a guideline to make my hyperbola. Okay, the asymptotes are just an equation of a line. So we do ours a little bit differently. We say take whatever the y is. The y is y plus 2. Find me that we can take out the b, because that one we'll work out ourselves. We can find the slope, and then we put x minus 1. Start like this. If you struggle with the asymptote, take whatever it says for y up there, put it here. Whatever it says for x, put it here, like you're building this. Your slope is your change in y over change in x. So find the y, go to the denominator, take the square root of that. So that's a 1. Find your x, go to the denominator, take the square root of that. That's a 2. And we leave it like this. However, because we're doing both lines at one time, we're going to do a plus or minus. Now all we have left to do, because nobody's a squared out here, they have to be a line. All we have left to do is solve for y. So just move the 2 over. And you can leave it like this. This plus or minus makes it 2 equations. But you can leave it just like that. So an easy way to do the asymptotes without getting too hung up over that formula. It's really your slope, which is change in y over change in x. And you're not using any squares in your line. So get rid of those squares on the bottom. The rest should kind of work the same. The foci, again, come outside. And there's no directors, of course, but there's no covertices. We need a covertice to make the box, but it does not sit on your hyperbola. So technically, we don't really call it a covertice. Okay? Now, the x comes first, so the x is our transverse axis, which means it's going to come off the x. Right? It's coming off the x. So set up your A and B and find C. Set this up first, find C, and then start from there. Take your center out the same way, the x first, negative 3, 2, negative 3, 2, make a little translated one if you need to. The major goes up 12, over 12 to the side, over 12 to the side. If it helps you, put this in the middle, and if I'm moving 12 over, if I'm adding 12 to this is going to give me at 9. So if you want to put it here, or did I put it somewhere else, I put it over there. This is going to slide me to 9, 2. If I go 12 this way, this is going to give me negative 15, 2. Up and down, we need them to make the box. So we're moving 5 up. So this is negative 3, positive 7. You don't need to keep track of those. You just need to put your dot there. Make the box. Send your asymptotes through. Use your vertex to make your two little parabolas. It's like a little parabola. And where did the focus belong? Inside of your parabola. So now, you can find me your focus, because your foci points, because your foci moves 13 away from this guy. So add 13, so that's at 10, 2. Subtract 13, that's at negative 16, 2. And the equation of your asymptotes. Start like this. Y minus 2 equals plus or minus your slope, x plus 3. Your slope is the change in y. Take the square root, 5, over the change in x, 12. There's your equation of your asymptotes. So just add the 2. And you can leave it like this. It should be equations of a line. No squares in there. Good? You with us? You okay?
I didn't think so.
No questions? We're good. Okay. Okay, again, you got a subtract, and you got 2 squares, so you know this is going to be your hyperbola, because you have a subtract in there. So set it equal to 1. So the first thing I need to do is set it equal to 1. I divide everybody by 6. And now I got an equation of a hyperbola. This is my first term. It's coming off the x's again. Yeah, I got some radicals in there, but where's your center at? 0, 0. So with the radicals, it's a little bit easier with the 0, 0. If I'm going to come across here, and I'm going a across, this is at radical 3, 0. This is at negative radical 3, 0. If you want to just say plus or minus radical 3, 0, because you can't resolve that anymore, that's fine. Your foci, you're at radical 5. So that's your plus or minus radical 5, 0. That's your foci. Your asymptote says take your y, get rid of the squares, no squares in a line, plus or minus the slope, x. Your slope says change in y, take the square root under y, take the square root under x. Now if you want to leave it like this, that's fine. Or you can even put it all under 1. We don't have to rationalize your radicals. You need to keep them reduced, of course, but we don't have to rationalize them. So it doesn't matter if you left it like this or you left it like this. Good? Okay? We had to complete the square. So, get your y's together, get your x's together. I put my y, since my y was minus, I put it over here. So I pulled my x's together, just in case you had trouble starting this. I did my y next, because that's where my minus was for now. I moved my 18 to the other side, so I take the opposite, remember. And you're going to add 2 things. The coefficient of these guys has to be a 1. Has to be a positive 1. So you're going to have to factor out a 9, just out of your x's. And we're going to complete that square. The factor for this guy, this also has to be a positive 1. So be careful on this. You have to factor out a negative 1. And then we're going to add to the other side. So it's half a negative 4. Negative 2. What's 2 squared? 4. So I bring down my 9, and I also distribute it here and put it over here. I've got a minus, which is exactly what I knew that I had a hyperbola, was half of 6. So I've got y plus 3, what's 3 squared? 9. So I multiply this, and I get negative 9. I add these guys up, and it gives me 9. Okay, so now, I've got a hyperbola, I've got to subtract in the middle, I've got to divide and make this equal to 1. So this comes out, a 1 on the bottom. I find it helpful to keep the 1 on the bottom. This is your a squared, that's first, this is your b squared. And you should be able to find the rest from there.
9 greater than 1.
But in an hyperbola, it matters who comes first. In an ellipse, it says who is the biggest one. Because on an add, you can add either way. You can put the x first or the y first, you'd never be able to tell, right? So an ellipse says who's ever greater. An ellipse says this. I can do it this way. This is an ellipse, right? But I can also write it like this. Because in an add, it's commutative. So to tell the difference from an ellipse, it's who's ever the larger number. To tell the difference in a hyperbola, subtract makes a difference, so it's whoever who comes first.
But if you group the y first and then the x, then
If you group the y first, you'd still have your negative, though. You would have to do this. Negative y squared minus 6y. You still have to factor out your negative 1. So bless you. So then that first one would be negative. So you want your subtract to be in the middle.
how do you get your full size of the one?
So your foci is c squared equals a squared plus b squared. So we put in your c squared. We said 9 plus 1 is 10. Square root of 10 is c. So because it went off of your vertex, you don't have your center, and it's a radical 10, you don't have to really give them to me separate. If you notice, it comes off of this one. Sometimes it helps just to make that translated axis. So here's my center. My center's at 2, negative 3. Just my x is moving. So 2 plus or minus radical 10, negative 3. Yeah, there's nothing to resolve for that, so you can leave them as a plus or minus. Jeremiah?
Hold on, understanding the asymptote.
The asymptotes are just these lines that help you guide this. An asymptote, remember in a trig function? Remember trig for, when we do trig, we say at 90 degrees we have no value of tangent, right? So we had these little guys here. And our trig for tangent, our function for tangent went like this. It never touched those lines. These are asymptotes. This was an asymptote. Couldn't use these guys. So now, these work as an asymptote. They work as a guideline so that you can see how wide your parabola should be, which makes your hyperbola. But you're making like, so how wide should I make this? If I don't make this box, I don't know, were they narrow? Were they wide? So I make this rectangle, and when I take the diagonals of that rectangle, it gives me a guideline to make my hyperbola off of. To make the equation, it's a line. It's a line. So start like this. Y plus 3 equals plus or minus your slope, then whatever x is, x minus 2. Now your slope is always change in y over change in x, right, of a line. Rise over run. So to get the slope, you say, go to the y, take the square root of that guy. Go to the x, take the square root of that guy. Plus or minus, because we have 2 of these. Now all you have to do is move the 3 over. And you can leave it just like that. If you resolve them, you can make them to 2 lines, that would be fine, but you can just leave it like that. If actually you put this in your calculator, watch, if you put this in your calculator, I just got to change mine. If I put this in my calculator, negative 3 plus 3 times x minus 2, and negative, whoops, oh, where am I in mode? I'm in the wrong mode. negative 3 plus 3x minus 2. I'll just show you a little, if I can get this out here. It won't take my insert. Okay, and I'm going to put the other one in negative 3 minus 3 times x minus 2. These are your two equations. Watch what happens when I graph this. These are two lines. There they are. And they cross right here. Where did they cross? They crossed at my center. They crossed at my center. And where was my center? At 2, negative 3. See it? 2, negative 3. They crossed at my center. So if you put them in your y1 and your y2, they have to cross at your center. And then you know you got the right equations. If you have a better calculator than this guy, I hope. Some days it works so good for me. And then some days not so good for me. This guy, when we do this, this was not a hyperbola because it's equal to 0. These all canceled out on the right-hand side. Don't forget, watch that negative when you group those y's. I'm going to put your negative one in the middle, second, because that's where your hyperbola goes. Yeah. And then this, hopefully we went off of a y. This one went off of a y. We grouped our x's. Let's group our x's. 2x, and I have, sorry. We'll put your y's first because the x's subtract. Minus x squared plus 2x, and we're going to say move the 62 to the other side. So take out your 9, take out your negative, don't forget to take out this negative. Usually that's what messes everybody up. I'm just going to add to over there, negative 62 plus something plus something. So half of 6 is 3. 3 squared is 9. Pull the 9 down and distribute. Minus half of negative 2 is negative 1. 1 squared is 1. Minus 1. So when you add up all of these, you get 18. And divide everybody by 18. So you get y plus 3 squared over 2 minus x minus 1 squared over 18 equals 1. And your first one is your major. So notice it goes off the y now. It's a y, it's called the transversal axis. And everything else should work the same. Make sure you take the h out of that guy first. So 1, negative 3 is my vertex, my center, sorry. Okay, you make your translated axis if it helps you. Square root of 2, square root of 18, square root of 18, square root of 25, square root of 16. So it's a little bit more than 4. You know, so if you kind of judge for the 4, that'll help you figure out this a little bit better. But, you know, just make sure you reduce your radicals. Take a little sketch of what we see, one step at a time. So we say we have, that's not that great. We have foci at negative 1, positive 2, and 5, 2. Guys, I need it quiet. So foci tells me it's on the major or the minor axis? Major. So which one will be the major axis? X. So the X guy is coming first. So it's going to look like this. So we're going to start like this. This gets an a squared. This gets a b squared. So the foci gives me which letter? A, B, or C? C. But my problem is I need to know the vertex. Because C is the distance from the vertex to the foci. So can I find the vertex that is smack in the middle?
Yes.
Good. I take the average of the x's, -1 plus 5 divided by 2, and it's staying right there along my y. So where's my center at? 2, 2. Let me put some color. So my center is at 2, 2. Okay, so can I fill something else into my equation? Well, yeah, the H and the K, let's just put our thing in here. And we know C. So what is C? The distance from the center to the foci. 3. Good. Okay, so we've kind of exhausted that part, right? We've exhausted that piece of information. Now we go on to our next piece of information. Our vertices are at 0, 2, and 4, 2. 0, 2, and 4, 2. These are your vertices. Looks weird, but which way is my hyperbola going to go? Out to the sides, right? And does it encompass the focus? It's got to go this way. Your hyperbola is going to go like this. Now the distance from the center to the vertice is which letter? A. So what is A? 2. Everybody okay with 2? Our center is 2, 2. Our vertice is 4, 2. So we moved over 2, right? However, now I know A, so this is 2 squared. All I need to know is B. You can give me any more information, but I know something about B. I know that C squared is equal to A squared plus B squared. Well, it's minus for the ellipse because you want to be inside, but in the hyperbola, we want to be outside of that box, so we're going to add. So C squared is 9, A squared is 4, and no, all we need is B squared, so subtract 4, and B squared is 5. We don't care about B, we just care about B squared. 2 for this, for A, the distance from your center to your vertex. So my center is at 2, 2, my vertex was at 4, 2, so it's a distance of 2. It's kind of awkward to look at a hyperbola because it's not like an ellipse or a circle where you're encompassing it. It's outside of it, the focus. So now we have everything. X minus 2 squared minus y minus 2 squared over 4 over 5 equals 1. There. See, we got that from the foci. See, we first had to find the center of this because C is the distance from the center to the foci. So we said the center has to come smack in the middle of my two foci, right? We took the average of the x's, -1 plus 5 divided by 2, the average of the y's, 2 plus 2 divided by 2, and we got our center at 2, 2. So we then said from 2, 2 to 4, 2, this is 4, 2. This went, no, sorry, this is 5, 2, 5, 2. From 2, 2 to 5, 2, it went 3 units over. It might help you to write the coordinates on the graph a little bit. So don't forget the foci is outside of this side. That's why it looks weird to you. The vertices, usually your ellipses, your vertices outside, your foci inside, but the hyperbola is opposite. Okay? Good? All right. So work with what you have and build up. Okay? This tells me, okay, I have a hyperbola with vertices at 3, 1, 3, 1, and 3, -5. Which way is my hyperbola going off? The y. Good. So I might want to start like this, guys. I might want to start like this. Where does my other axis have to be? Smack in the middle, right? Isn't that where my center's going to be? So can we find your center? 3, 1 plus -5 divided by 2. 3 -2. Everybody can find the center? Okay, it's just the average of the x's, average of the y's. Midpoint. So, and it's because it's a y, I can do this now. Let's set this part up. Minus x minus 3 squared. I'm going to start just like this. I know my center. I know my y comes first. This is my a squared. This is my b squared. So now, vertices gives me which letter? The a, b, or the c? The a. So the distance from here, it's probably easier here to here, is what? 3. Okay. The distance from there to there is 3. So now I can come back over here and say 3 squared, 9. Okay. Now, I've exhausted my vertices. I need to move on to my next thing. My next thing says, oh, I gave you an asymptote. So, it's after they made the equation. But all I care about is the slope. Because the slope tells me change in y over change in x. Right? Okay? So my slope is -2/1. And it's the change in my y. So take the square root of this guy. So what's the square root of 9? 3. Over the square root of b, which I don't know. But can I make this a little proportion here? A little ratio? Can I do -2/1 is equal to 3 over b?
Yes.
I'm going to cross multiply. It's okay if you get a fraction. I'm going to divide by a -2. B shouldn't be negative. So what happened here?
Where'd you get that 3 from?
The 3 came from underneath the square of here, 9.
You choose the negative one instead of the positive.
Oh, I chose the negative one. Let's choose the positive one. Thank you. I missed that one completely. Just so that we don't end up with a negative for a distance. And because this works both ways, you can just take the positive one. Make your life easier. Now, I have b. It's okay that it's a fraction. So I come up here, if I plug b in, what do I still have to do? Square it. So that becomes 9/4. Now, there's one more step. Remember we said we can't have a fraction in the denominator. So if we flip this guy, this 4 comes up here. So we end up like this. Minus, bring the 4 up. We keep it down here when we want to find b. But in the final equation, we can't have a fraction in the denominator. This is a tough one. We had to use your slope. And we had a fraction that we ended up with.
I don't understand how you did the asymptote. Like
How I use the asymptote? Well, remember when we did it the other way? We did like y. Let's work this backwards. Remember, we're going to do one from your homework, guys. Remember when we did this to find the asymptotes? It's kind of backwards now. So instead of doing this part, all I really need to know is my slope. Change in y over change in x. So, because isn't it under the y guy, under the x guy? So I know the under the y guy. I can find out under the x guy. And it has to be proportionate to 2/1. So I'm using the slope to go backwards. Okay? Do number 41. Your homework. There's one that's really hard. I'm going to take that out of there.
Is it 47?
All right, cross out 47. And there's another one that's really hard.
41.
Passes through, does that mean that's the
Passes through. We'll do a passes through. All right, let's just do a let's go to number 33. I think we have about a lot of these. How about I got number 47. That's fine. Let's go to 39. So let's do 39. This might make a little bit more sense. Okay, ready? So my vertice is at 4, 1 and 4, 9. So which way is this going off of? The y. Good. So right away I know my y is coming first. I know it's going to look like this. Over a squared, because a squared always comes first. So start like this. Do one step at a time. Okay, so now, I know this is my major axis. I know that my hyperbola is going to go off of this guy. Okay, I know it's going to look like this. So my vertices gives me which letter? A. A, B, or C I need to know. I really need to know A and B, but if I find C, I can always find B. Now, but I need to know my center. So when you translate when you do a translated axis, you should kind of see that, oh, I need to know that guy in the middle. So I know this has to be a 4, and all I have to do is average this part. So 9 plus 1 is 10 divided by 2. There's my center. So I can also change this. There's my 4, there's my 5. And what's the distance from here to here, to 4, 9? What's this distance? 4. That's my A. Oh, so now I have this guy. 4 squared. Okay, so now I got a lot out of that for a vertice, didn't I? I can tell which way it's opening, so I can set up my equation. I can tell A. So now I go to the next one, my foci. My foci, remember, has to come inside my little parabolas. So 410 and 440, right there. So what does that give me, my foci? A, B, or C? C. So let's go with the 40. The distance from here to here at 40 is what? 5. I still need B, but I have a little equation. So I plug in my C squared, 25. I plug in my A squared, 16. So if I subtract 16, B squared is 9. That's all I care about is B squared. So just take B squared out and put in a 9. And just rewrite your equation. Okay? Try the other ones. The passing through is a little tougher.
Is that cross out 41, right?
Cross out 41. I know that's going to make you panic. Passing through.
No, we don't have a passing through.
You do have passing through. All right, cross out the passing through. Cross out anything that says passing through. So it only probably leaves you with a couple, right?
5.
One passing through? All right, hang on. I'm going to give you this to start looking at this. This is part of a review with ellipses. And we're going to bring it back tomorrow because we're going to do this. I'm just going to cross some out. Did you get it?
Yes.
Okay, cross out number 3. Am I good so far? And 6 and 7. Cross out number 3 and 6 and 7. Those are parabolas. The other two on here are ellipses. 3 and 6 and 7. So, turn to number 8 on this for me for a minute. Turn to number 8 on this. This is a good one to do. Look at number 8. It wants to know, what is this an equation of? All I want you to do is identify this. So I see 2 squares. So the only thing it cannot be is what? A parabola. It could be a circle, it could be a hyperbola, it could be an ellipse. So I know I need to get the y to the other side. So I add that to the other side. And what is it? Could it be a circle? No, because these two are not equal. So what is it when I have a plus? Ellipse. Okay?